Tuberculosis was, and in some places still is, one of the most deadly infectious diseases that exists, with 10 million cases and more than 1.6 million deaths in 2017 alone. Tuberculosis is caused by the bacteria Mycobacterium tuberculosis, which is able to spread through the air, where it gets inhaled and infects the lungs. The symptoms of the infection include fever, sweating, weight loss, and because the coughing can be so rough and agitating, the tissue in the nose and throat can become inflamed and damaged, and blood can appear in the spit and mucus. Tuberculosis can spread when an infected person coughs, sneezes, or even talks to someone who's standing too close to them. A vaccine was developed to prevent tuberculosis, called the BCG vaccine. But there were some follow-up studies across the 20th century that found some conflicting and somewhat concerning data. Some studies suggested that the BCG vaccine raised the risk of lymphoma and leukemia, while other studies showed a weak or a non-existent or even a negative relationship. Because of this ambiguous, conflicting, but altogether concerning data, long-term studies were established to observe lifetime effects of the BCG vaccine, to get a better picture of what exactly is going on here, and what the actual lifetime risks really are. The study that I want to tell you about is a 60-year follow-up study on almost 3,000 people from 9 different American Indian and Alaskan Native tribal groups. 1,540 of them were given the BCG vaccine, and 1,423 of them were given a placebo. The median age at vaccination was 8 years old. The range was about 5 to 11 years old, so these were all childhood vaccines. And the study controlled for sex, living region, alcohol overuse, smoking, and previous history of tuberculosis infection. One of the most shocking findings of the study had to do with the incidence of lung cancer. The study found that people who received the BCG vaccine were less than half as likely to get lung cancer than those who didn't. Here's a passage from the study. Quote, "The results of this study are consistent with existing research indicating that BCG vaccination is associated with diverse immunological effects independent of TB, of tuberculosis. We initially anticipated that BCG vaccination might protect against lung cancer by preventing TB infection, as the granulomatous inflammatory response from TB may be favorable to malignant neoplasms known as scar carcinomas. Previous studies have suggested that persons infected with TB may have excess mortality from lung cancer, especially among heavy smokers. Here, BCG vaccination was associated with lower risk of lung cancer independently of TB. Only 3 cases of lung cancer, all among the placebo group, were found in participants with prior TB infection. This suggests that the association is mediated directly by the immune response to BCG." Unquote. However, reading further into the paper, the authors explain that their study did not control for confounding variables relating to lung cancer, like obesity, inactivity, secondhand smoke exposure, that kind of thing. The authors say in their conclusion, quote, "While BCG vaccine was associated with preventing TB in this clinical trial with long-term protective effects, the observed decrease in lung cancer was not associated with prior TB infection. The mechanism of this observed protection is unknown, but the association is large and scientifically plausible. We favor trained immunity as a hypothesis." Unquote. Okay, so to explain this in a little less technical terms, what this means is that they saw this really big protective effect. They saw that the tuberculosis vaccine led to a pretty big decrease in the risk of developing lung cancer. But because they didn't control for all of the variables that might play a part in lung cancer, they can't say for sure that it's the vaccine causing this, although there is good medical reason to think that the vaccine is playing a big role. So they're hypothesizing what exactly could be happening here, and they come up with several hypotheses. Perhaps the BCG vaccine creates antibodies that are cross-reactive with pathogens that could provoke lung cancer, so it would be a coincidental secondary benefit. Although the researchers say that this is unlikely, because no such cross-reactive antibodies are known. Basically, the antibodies created from the BCG vaccine, none of them are known to play a role in protecting from lung cancer, so this is probably not the explanation. The second hypothesis is that the BCG vaccine stimulates immune memory, and this makes the immune system respond faster and more effectively to other pathogens. And in this case, if you have a pathogen that might be carcinogenic, that might cause lung cancer, the immune system is simply stronger and faster and more effective at responding to this, and so you have this kind of generalist global protective effect. The third hypothesis has to do with trained immunity, which is the hypothesis that the authors generally favor. This hypothesis is that monocytes and natural killer cells, which are cells of the immune system, these cells will respond to the BCG vaccine in ways that might make these cells more responsive against malignant lung neoplasms, or lung cells that are reproducing in an uncontrolled manner, i.e., cancer. This is the explanation that the authors think is most plausible. But as you can see, more research is really needed to dig into this relationship and to find out exactly how it works. But even if we don't know exactly how it works, the good news is quite apparent. The tuberculosis vaccine appears to have a strong protective effect against not just tuberculosis infections, but also lung cancer. And that's good news, no matter which way you look at it.